Hello and welcome back to this week's Everything is Mathematical challenge. I hope you enjoyed trying to figure out the strategy for the game of How. The game of How is a member of the Nim or Marienbad family. Now all of these games have the same feature that they have similar things in different piles. So here we're using matchsticks in terms of letters, but you could use coins or sweets, whatever, as long as they're in different piles of same objects. Now the thing about the Nim and Marienbad family games is that they all have definite strategies, which if you know, you can always win. Let me show you how. To solve this problem, you need to use a bit of binary arithmetic. So here we have the numbers 0 to 6 written in the normal base 10 that we all know and love. Here we have converted them to base 2, or binary. Now it sounds complicated, but it gets a lot easier with practice. So you go all the way from 0, which is 0, 0, 0, to 6, which is 1, 1, 0 in base 2. So having done that, we then look at the How groupings that we have. So the H has 5 matchsticks, which in base 10 is the normal 5, and in base 2 is 1, 0, 1. The O has 6 matchsticks, which is 1, 1, 0. And W has 4 matchsticks, which is 1, 0, 0. And that gives you 3, 1, 1 when you add up the columns, which is the Nim sum. And that's very important for part of the strategy. So this is how the start of the game is set up. You have 5 matchsticks, 6 matchsticks, and 4 matchsticks. And as we just calculated, this has a Nim sum of 3, 1, 1. Now each of these numbers is odd, and that's going to be important later. So the first thing is I go first, and I make sure to take away 3 matchsticks. If we calculate the Nim sum of that one, exactly as we just did, we find that it's 2, 2, 0. Even. All of these numbers are even, so I'm giving my opponent even numbers. So now they'll come along and they can take away, say, another 3 of the O. And that gives a Nim sum of 1, 2, 1. It doesn't matter that he has one even number there, he has 2 odd numbers as well. So I'll come along and I'll take away 3 from the W. Now again, calculate the Nim sum. That gives us 0, 2, 2. Again, all even. My opponent is getting a bit worried by now, so they'll come in and they'll take away these 2 of the H. So all we have now is left is the O and the W that was. And that has a Nim sum of 0, 1, 2. Again, this 1 is odd, so that puts me in a prime position. All I have to do now is take away 2 matchsticks of the O, giving a Nim sum of 0, 0, 2. And my opponent is snookered. Because if he takes this one, I take this one. If I take that one, he takes that one. So let's say the opponent will take that one, I take this one, and I win. So I won that round, but I know the strategy, so it wasn't that difficult. What is that strategy? Well, it's all about evenness and oddness, and that's what I mentioned in the last game. Let's take a look at the Nim sums that I wrote down. We start off such that all digits are odd. I take away a number of matchsticks such that I make all digits even. My opponent then has no choice but to make at least one of them odd. Here he made 2 odd. I make it even, they make it odd, I make it even. So it doesn't matter how many matchsticks you start off with. As long as you can always leave your opponent with an even number of matchsticks, then at some point you'll get down to 0, 0, 0, which is even. And since you have left your opponent with an even number, it must mean that you have taken the last matchstick.